Welcome to video lesson number 13. Today's lesson is on patterns and sequences. For today's lesson, you will, as always, need your TOC number 13. That's the notes you were given in class. Today's are bright green. You will need a pencil or pen to take notes, a highlighter, marker, or colored pencil. And for this lesson, you can use a calculator. So if you have one at home, or you can use your cell phone or device or computer, you can use calculators when you're taking your homework quiz. All right, look at video lesson or the TOC number 13 notes. With sequences, we're going to start with talking about two specific types. There is arithmetic or arithmetic, and the second is geometric sequences. I know in 5th grade you guys learned about that there is such thing as sequences where the numbers are a pattern. These are two specific types, and we're going to talk about what those are. So for the first one, it's an arithmetic or arithmetic sequence, and that is a series of numbers that are formed by adding or subtracting, and really, I don't know if your teachers told you this, but there's really no such thing as subtracting. You're really just adding a negative number, and that's the same thing as subtracting. So sometimes you'll hear them say, oh, refer to something as a negative number, and that is why. So you're either adding or subtracting the same number each time. So if we look at a sequence and we start with number 1 and we added 2, and we get to 3, and then we added 2 more, we get to 5, we added 2 more, we get to 7. So you're adding the same exact number each time. And that number that you're adding is called the common difference. And that is the number you're adding or subtracting to each term in an arithmetic or arithmetic sequence. So an easy way to remember this is arithmetic starts with A, and so does adding. So, and you can also think of it as it's the beginning of the alphabet, it's the first thing you've learned. All of that stuff will help you. Geometric sequences are a series of numbers, I should say numbers, not number, formed by multiplying or dividing. And if you in the last unit, we talked about that dividing a number is really the same as multiplying by the reciprocal or the fraction. So it's either multiplying or dividing the same number, just like the arithmetic sequence. You're multiplying the same exact number each time. And that number that we're multiplying or dividing is called the common ratio. And that's in a geometric sequence. Geometric, an easy way, geom, it has an M in it, geometric, has for multiplying. There's not a really fun way to remember geometric, but anyway. And just a real quick way to recognize the difference is that you're either going to be increasing or decreasing with your series of numbers. If you're increasing by a little bit each time, so it's getting bigger, but it's getting bigger slowly, then chances are you are adding. So it would be an arithmetic or arithmetic sequence. If you're getting big really fast, like you start with 5 and by the third number you're in the hundreds, then that would be a geometric or multiplying sequence. So remember that if you're increasing, then you're either adding or multiplying. If your sequence is decreasing or going down, then it's the opposite. So if it's going down by a little, instead of adding, you'd be subtracting or adding a negative. And if it's decreasing really fast, like I'm going from 200 to 100 down to 50, then that would be division or multiplying by the reciprocal or the inverse, and that is geometric. So let's look at some sequences and let's see if we can determine whether it's increasing or decreasing, am I adding, am I multiplying, that kind of thing. So if we look at number 1, we have 14, then 26, then 38, then 50, then 62, then 74. I'm getting bigger, but I'm not getting bigger really fast. And let me show you the difference. So if you look down at number 4, I'm also getting bigger, 5, 25, 125, 625. But if you look at the difference, so number 1, I'm going from 10 to 20 to 30s to 50s, still not getting big very fast. I'm only getting big by like the 10s. With number 4, I go from 5 to 25. By the third number, I'm in the hundreds. By the fifth number, I'm in the thousands. That's what we mean by increasing really big or a lot. So for number 1, we are increasing and we are adding because I'm not multiplying. I'm not multiplying. It's not getting big enough, fast enough for me to be multiplying. So now once I figured out I'm increasing, I look and say, okay, what am I doing each time? You do not have to start with the first number. I would probably look at 50 right there in the middle, because 50 is an easy way to look and see, okay, how much bigger is it getting each time? So if I look at what am I doing to 50 to get to 62? Well, I'm adding 12. So let's go back and see if that works for each one. 14 plus 12 would give me 26. 26 plus 12 gives me 38. 38 plus 12 gives me 50. We already said that that's how I got to 62. And then if I was at 62 and I add 12, I get to 74. So that would be my common difference, which I know is confusing because difference means to subtract, but it's the difference between the numbers, if that makes any sense. In that common difference, or that number I'm adding every time, is 12. So let's look at number 2. Number 2, I'm going from 33 to 30 to 27 to 24. I'm going down, so I'm not increasing, so I'm not going to look at increasing. I'm going to go over here to decreasing. And I have to ask myself, am I getting smaller slowly or am I getting smaller really fast? So it looks like if I'm at 33 and I go to 30, then I'm just going down by 3. So let's see if that works every time. 30 minus 3 is 27. 27 minus 3 is 24. 24 minus 3 is 21. 21 minus 3 is 18. Yep, that's pretty much working for every single one. It's important that you check every single number because sometimes it may do it for the first couple and then change on the fourth number, and they will try to trick you that way, so be careful. So on this one, my common difference, and this is where you're going to see a difference, I am subtracting, my common difference is -3 because I'm subtracting. So this is where you're going to see the difference between an adding sequence and adding a negative. So for number 1, I'm increasing, I'm getting bigger, so it's a positive 12. My common difference, because I'm getting smaller, it's like I'm subtracting 3, which is really adding a -3. I know, completely blows your mind, but hang in there, we're going to get there. All right, number 3. If we look at number 3, our numbers are getting smaller each time. So we're either subtracting or we're dividing. And I guess you can probably guess, and since we already did subtracting, we're going to be dividing. So if we look at 48 to 24 and then 24 to 12, what am I doing each time? Technically, I'm dividing by 2. I'm cutting them in half. However, because we don't ever truly divide, we're just multiplying by the reciprocal, my common ratio is 1/2. That is the same as dividing by 2. Okay? All right, last example, we already kind of talked about this one. We know we're increasing and we're increasing by a lot. So we're going to be multiplying, but we have to figure out what that common ratio is that we're multiplying by. So if I look at 5, how am I getting to 25? Well, I would be multiplying by 5. 25 multiplied by 5 is 125. 125 multiplied by 5 is 625. So my common ratio on this one is 5. and that's the number that I'm multiplying by each time. So that's what those words common difference and common ratio mean. It's the number that I'm using to create the sequence. All right, flip your paper over. We're going to look at some examples on the back. So here's the things that you're going to see on your tests and quizzes. You're going to be given a sequence, and they're going to say, they're not going to put a little square over here that says, oh, hey, this is an adding sequence. You're going to have to know, am I adding, am I multiplying? And you're going to have to be able to identify the common difference and ratio, and you're going to have to be able to fill in missing numbers, extend them a couple, like 2, 3, sometimes they'll say, what is the 7th sequence? And you also have to be able to write the rule or the expression that they're using to make that sequence. So if we look at this first example, I've got a little input-output box. So think of it like a computer. What goes in, what comes out. So if we put 5 in and out comes 15, I have to ask myself, well, how did I get there? Well, to go from 5 to 15, I got 2 things I could do. I can multiply by 3, or I can add 10. So then let's look at the next example. If I was at 15, if I multiplied that by 3, I'd get 45. I can't go to 45 because the next number is 35 after that. So it's not going to be multiplying by 3. So let's try adding 10. If I add 10, I get 25. That could work. And then if I plug in 25 into my machine, add 10, and out comes 35. That works. If I continued the pattern, put 35 as my input, my rule says I'm going to add 10, so my final number would be 45. Okay, so my missing number here is 25. It is a common difference, which is why it's highlighted red, and that difference would be a positive 10 or just 10. And my expression is the rule that I'm using, which this is how we're going to write it. Don't get confused. It's going to have a letter. It's okay. A number plus 10. That's what that N stands for. We don't know what that number is. It could, and it's changing every time. The first time it was 5, the second time it was 15. So just know that that's what that N is standing for. It's a variable. It changes from each step. Okay. Looking at the next one, we have another one, and obviously it's a subtracting because I tell you over on the side it's a subtracting sequence. So let's plug it into our machine. In goes 54, out comes 49. How did I get there? Well, there's nothing I can divide by to get to 49, but I can subtract. 49, if I used my fingers and I counted up 50, 51, 52, 53, 54, I would be subtracting 5 each time. So let's see if it continues to work. In goes 49. If I subtract 5, I should get 44, and that's what's there. Plug in 44, subtract 5, out comes 39. Plug in 39, and here's where my answer is coming from. Subtract 5, and you get, oops, I put 35. It should be 34. My mistake, that should be a 34. Okay, this is still a common difference because I'm adding or subtracting, but this time, instead of it being a positive number, it is a negative number to show it's going to go down, and that is a negative 5. And remember, subtraction is really adding a negative number, which is why we write our difference as a negative 5. My expression would be a number minus 5, or this is how you'll see it in 7th grade and at the end of this year, a number plus negative 5. Pretty fancy stuff, huh? Both mean the same thing. Okay, third one. We're almost done. Hang in there. Okay, obviously this one's a multiplying sequence because I told you over here. So we're going to plug in 1, out comes 5. Obviously, we are multiplying by 5. Plug in 5, out comes 25. Plug in 25, out comes 125. Plug in 125, multiply by 5, and I get, ding, 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 625. Plug it in both places. Now this time, because I'm multiplying, it is a common ratio, and my common ratio is 5. That means I'm multiplying by 5 each time. I don't have to put times 5 because ratio, the word ratio, tells me I'm multiplying. So I don't have to write times 5. And my expression would be a number times 5, and there's 2 ways we can write it. This is the fancy schmancy algebra way that says 5 times n, or 5 times a number, or you can write it with the x or the dot. Remember, we're getting away from using this x because we're going to be using x as a variable, as a letter. So try not to use this n times 5 and try to go to the big algebra way, which is 5 with an n right next to it. When they're smushed up together like that, it means multiply. Okay, last example, and then we'll be done. We have 28, then we're going to 14, then we're going to continue. So if I plug in 28, how do I get to 14? Obviously, we are dividing. So if I'm dividing, I'm going to be dividing by 2, because half of 28 is 14. If I plug in 14, we say, what is half of 14? 7. So we're going to fill that in. Plug in 7, half of 7 is 3.5. And with this division part and multiplying by a fraction, you are going to get decimals. And you can use your calculator, and that's okay. So then if I plug in 3.5 and I find half of that, I'm going to get 1.75. All right, so we're going to plug in 7 because that's what goes in the sequence. Our common ratio, be careful, we're multiplying by a fraction. Ratio means multiplying. So our common ratio is not 2, because that means I'm multiplying by 2. To show that we're dividing, we have to write it as 1/2. And our expression can be written again as 2 ways. We can either write that we're multiplying n, or the number, by 1/2, or we can write it this way, n divided by 2. That fraction bar means division. We're trying to get away from the division sign. And that's all she wrote, folks. It's time to show what you know. Log in and take your homework quiz.